just start this off by showing you guys something on my laptop, alright? I want to show you the equation of y equals x cubed. So when I activate this, it looks a little something like that. And I want you guys to note that we have a point of inflection right here, okay? Now let's take a look at y equals x to the power of 5. Looks a little something like that, okay? Now it's a little bit more boxy around the curves right there. And let's take a look at y equals x to the power of 7, or even more boxy, right? And let's take a look at y to the power of x, y equals x to the power of 101. Well, that almost looks squarish, right? But if I zoom in a bit further, you can see that it's actually curved there, right? It's just that it looks a lot more boxy than the others. But the point is, what every single one of these functions with y equals x to the power of an odd number, or every single one of these, they all have a point of inflection right in the middle, okay? And the first thing that they wanted for us to do in this question is to actually have an equation which has a point of inflection in it, all right? So this is one of our steps. All right, guys, so I want you to imagine that this is y equals x cubed, or y equals x to the power of 5, or y equals x to the power of anything that's odd, right? It's going to look a little something like this. It's always going to have a point of inflection right in the middle. And what did the question ask us for? It wants an equation which has a maximum, a minimum, and a point of inflection. So now that the point of inflection is done, great, that's fantastic. But what do I still need? I still need a maximum and a minimum. So what I can do now is just curve these around, and kaboom, I just created a minimum right here. Now I can also do the same with the top over here. I'm just going to turn it into a maximum like that, right? Now the only thing that I changed is I made, before it was going up, but then I made it come back down and cut through the x-axis, right? And over here, it was going down before, but I made it go up and cut through the x-axis so that I could have my minimum. So what I need to do is edit the equation y equals x cubed. I need to multiply it with something else and something else as well, so that I can have these two x-intercepts as well. So let me just explain that a little bit more, all right? Whenever I want to find my x-intercepts, I always let y equal to 0, right? And when y is equal to 0, then I have, x cubed times this, and then all of those things is going to equal to 0, right? X cubed equals 0. I'll have this bracket equals to 0, and I will have another bracket equaling to 0. And what this means is I actually have three x-intercepts on my graph, right? And I have 3 x-intercepts right here. Now let's try and okay, so what I want to do is just put in x into these, right? Because I know x is going to have to be in them. So x in here, x in here, x in here, and x in here. Now with the numbers that go inside there, that's what's going to affect where our x-intercepts actually are. Now since this graph, it doesn't matter where your x-intercepts are, it doesn't matter where your maximum is, where your minimum is, where your point of inflection is. The only thing that matters is that we actually have all 3 of them on the same graph. Well, that means that I can choose any numbers I want, all right? You know what? For simplicity's sake, I'm going to choose the number 1. Let's put a 1 in here. Let's put a 1 in here. Let's put a 1 in here, a 1 in here, a 1 in here, and a 1 in here. Now now what remains is my sign, okay? Now with my sign, I want to make sure that I have 2 different signs, since these 2 x-intercepts are on completely different sides to one another, right? They look like they're about the same number, just this one would be negative, this one would be positive. Let's just choose positive 1 and negative 1, positive 1, negative 1, positive 1, negative 1. Now let's take a look what happens when I actually find the x-intercepts of this equation right here. Well, what do I get? Well, I get x equals 0, I get x equals minus 1, and I get x equals to positive 1, right? Now all those 3 intercepts right there, well, that means I have negative 1 here, 0 here, and positive 1 there. And what I can see is I just created the same kind of graph, right? It's got those 3 intercepts there. And if you put this into GeoGebra just to check this out, then you'll actually get the exact same graph right here. It's just going to look a little bit nicer, okay? So this is definitely an equation you can use. You can change the numbers if you want. You can also put a product constant out the front here. So this could actually be 3x cubed, blah, 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 blah. And this would still work. You could even change this to x to the power of 5, I think, and that would still work. But yeah, there's a lot of things you can play around with, but this is the way that I kind of thought about it. So yeah, that is the second question, I think it is, of part A, or third question, whatever it is. Anyways, so yeah, good luck with your questions. If I want to find the gradient function of this graph right here, all I need to do is think about where my stationary points are and move my stationary points to the x-axis. So you see this point over here, right? I'm going to bring it all the way down, all the way to my x-axis right there. Okay, now I can see the stationary point is already on the x-axis, so I'm cool with that. Okay, now over here I have a stationary point. I want to move it over to the x-axis, so I'm going to put it over here. All right, now that all three of my my stationary points are on the x-axis, I can go ahead and think about where the gradient is, whether the gradient is positive or negative on each of these lines before and after the stationary points, right? So before this stationary point, well, what's my gradient? Well, this line here is increasing from left to right, which means my gradient is positive. And since my gradient is positive, well, for my new graph, I'm going to draw it on the positive side of this whole Cartesian plane. So imagine that this top half is positive, this bottom half is negative, all right? If my gradient function is positive, then I draw a stick in the, which is in the positive region, okay? Now, let's take a look at the line after this stationary point. So after that stationary point, it looks like it's going down, so it's decreasing. That means that after this little point here, I'm gonna have my gradient function decreasing. Now over here, my stationary point is just there, and before it, well, it's decreasing, right? So I'm going to draw it in the negative region, and okay, and between this stationary point and the next stationary point, it's decreasing as well. So I draw it in the negative region as well, and okay, between this point and that point again, well, it's decreasing, right? So I would draw my stick in the negative region, and then now over here from this stationary point and beyond, it looks like it's going up, yeah? So I have a positive right there. So then what my graph is going to look like is something like this. Yep. Okay, and then you're good, all right? Done. That's a gradient function.